Hi, I'm Welder Oliveira, a math and statistics tutor. Today we are going to talk about integral by parts. How can we solve this integral right here? One frequent doubt about the integral by parts is what part I call u and what part I call dv. How can I make that decision? What is some guidelines for I make a good decision? Well, we have to have in mind that what you call u, you need to derivate. And what you call dv, you need to integrate. So first of all, when you are facing the decision, you must be sure that what you are calling you are able to derivate, and what you call dv, you are able to integrate. But more than that, it is important that the decisions that you make simplify the expression. Let's see that. So let me leave this here. Let me put here a table in order to evaluate this expression right here. So this expression, I will divide it in two parts. One part will be the polynomial part x, and the other will be the exponential part. And here I will put a column for derivative, and here I will put a column for integral. Let's analyze the last one, the exponential. The derivative of the exponential is exponential. The integral of exponential is also the exponential function. So it does not matter if I choose to derivate or integrate exponential, I will have the same result. So I can use ex both as u and dv. The complexity of the task will be the same, and the result will not get the expression more complicated. Okay. But let's analyze now what happens when with a choice that we can make for the x part. So if I choose to call x equals u, I'm going to derivate it, and the derivative of x is 1. If I choose to call x dx dv, so I have to integrate it, and the integral of x is x squared divided by 2. I can do both calculations. We can do that. It is not hard. Both of it is simpler. But if I choose to derivate, I'm simplifying the expression. I'm taking an x and replace it by 1. That is nice. If I choose to integrate it, I will get a more complex expression. So the good choice here is to call u equals to, let me put here, u equals to x. Okay, this is the good choice because I will simplify the entire expression. So if u is equals to x, du will be equals to dx. Further, dv is equals to the rest of the expression, ex dx. Now I can integrate both sides, and I get, let me put here, v equals to, because the integral of dv is v, and the integral of ex is ex. So v is gonna be ex. Let's move on. Let me put it here. So let me call this integral I. So I is, by the integral by parts technique, I is equals to uv minus integral of v du. This is the formula for integral by parts. So I is equals to u, which is x, v, which is ex, right here, minus integral of v du, integral of v, which is ex, du, which is dx. See, the integral got simpler than the original one. If we have made the wrong decision, let's say if we have computed first here, instead of calling u dx, we have called dv equals to x dx, we will got the following expression for v. V would be x squared divided by 2, and we would have to put this here, right here on the integral, here on the integral formula. It would be x squared divided by 2 times dx, which would be, let me put it here, s squared divided by 2, du would be ex dx. So we will have a more complex integral than the previous one. Okay, for that reason, it's good to analyze here what we call u and what we call dv. So let's continue. So continue here, we have x, the integral that I want to compute is x, ex, minus the integral of ex is ex. So the integral will be ex. I can put in evidence because I can factorize it. It appears on in both terms. So this will be ex times x minus 1 plus a constant. So here is final answer. That integral have this result right here. Okay, let's see another example. So here we have the integral of x cosine of x. Let's do the table again. I will break it down here on two pieces, x and cosine of x. And let's see what is the work associated with derivating and integrating both expressions. Derivate or integrate cosine of x is about the same effort. See, the derivative of x is minus sine of x, and the integral of cosine of x is sine of x. So here is, let me put here, sine of x. See, is about the same effort and is about the same result, unless of the sign. When we do the same analysis for the x, we have the derivative is 1 and the integral is x squared divided by 2. So it doesn't matter if we what we do with the trigonometric expression here, what will turn the expression more complicated or simpler will be the choice that we make here for the expression x. So we choose to simplify it, and to simplify it we have to derivate it, and to derivate we need to call it u, because what we call u is what we are going to derivate. So here, as u is equals to x, du will be equals to dx, and the other part will be dv. dv is equals to cosine of x dx. Now we can integrate both sides, and we have the integral of dv, which is v, and the integral of cosine, which is sine, because the derivative of sine is cosine. So let's apply now the formula for the integral by parts. We have that the integral is uv minus integral of v du, which is u is equals to x, v is equals to sine, minus integral of v, which is sine, dv, which is dx. So this is equals to x times sine of x minus integral of sine is minus cosine. Doing the computation, we have here x, sine of x, negative and negative is positive, cosine of x plus a constant. So this is the final answer. What would have happened if we had done the wrong decision? If we have called u equals to cosine, so here is the wrong decision. dv equals to x dx. See, the trigonometric here will not got complicated. du will be equals to the derivative of this, which is minus sine of x dx. Okay, and here dv, integrate both sides, would be v equals to x squared divided by 2. When we plug in the formula, see, we will have u, which is cosine of x, times v, which is x squared divided by 2, minus integral of v, which is x squared divided by 2, times dv, which is here dv, which du dv, which is, let me just, here is du, excuse me, here is du, okay, so in du is minus sine dx, minus with this minus here will be positive sine of x dx. See that we have got here a more complicated expression for the integral than the previous, than the original integral. So the right decision makes difference in computing integral by parts. So this is the video that I have planned for today. Hope you have enjoyed, and see you on the next video about some calculus topics. See you, bye.